Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Twit specials is provided by Cashfly at CACHEFLY.com.
Hi, I'm Dr. Kiki here at Day 1 at Maker Faire. It's Education Day. It's a day for the kids, young makers, showing them what it is to be a maker. We get a sneak peek. It's not open to the public today, so we're going to see 2,000-pound iron giraffes singing Tesla coils and a bunch of young kids making stuff. Come on, let's check it out. So Dale, can you tell us how's it going this year at the Maker Faire?
Well, if you just look around, you see lots and lots of people here, and it's going really well. This is our 10th big fair, 6th in the Bay Area, and I got a great team. We kind of know how to do it, and more people are coming, and more people enjoying it, and it actually has gone very smoothly for our first day.
How many people do you expect to come here this weekend?
That's a good question. We had about 75,000, 80,000 last year, and we think we'll top that this year. It looks more crowded today than it was last year. So, we might get up in the 90s maybe.
That's really, really an awesome number. Not just people who are coming to appreciate what's at the Maker Faire. How many makers do you have here?
Well, we have like 750 individual exhibits from makers, and sometimes that's 2 people, 3 people, or a group of people. So it's over 1,000 makers that are participating and creating this fair with us.
And what's the philosophy behind the Maker Faire for people who might not be familiar with what's going on here, and they're just like, makers, what?
Yeah, well, in the simplest sense, it shows what you can do. It's just an invitation to have people bring something they've been working on in their backyard or basement, and often they're working with other people and collaborating on things. So it's experimental. The things that are here are things we tend not to see in a store. We tend not to find normally around us. So people have unique ideas. Sometimes it's driven by a sense of personal expression, this says something about me. And the smallest crafts do that. I mean, even cooking, right? It says something about yourself when you learn to cook and you become a good cook. Well, think about that around gadgets and robots, too. So there's lots of different flavors here, lots of different things going on.
What kind of a maker are you?
I like to garden and cook, and at the heart of it, I like to learn. Making is just a reason to learn something, figure it out. I'd like to make cheese, for instance, and that's biology and chemistry and lots of things together there. But it's a how old? Thousands of year old process. But each of us can kind of discover it and learn to do it in our own way.
And what do you hope that people are going to take home from visiting one of the Maker Faire events around the country?
Well, obviously, we hope we inspire them, and we know we do. So we inspire them to be makers themselves, to almost not only just use your hands, not only just make something, but there's a sense of optimism here of hey, I can do it, right? That, I think, is, in a nutshell, almost the maker culture. I can do something.
Yeah, we can all do something.
Right.
So from this weekend, O'Reilly Publishing and Make Magazine and the Maker Faire, is this something, is Make Magazine really the way that you can keep in touch with the maker community in a year-round sense? Like, what are you doing in addition to these fairs?
Great. Well, in addition, we do have the magazine, which is print, but we also have online, makezine.com. We have Make Projects, where you can get recipes and instruction sets for how to do things yourself. We have Maker Shed, which is also here, which sells kits and things, and particularly focus on how do you get started. I want to do something. How do I build my first robot? Or how do I get into electronics? That's where we'd like to help make it easier for you to do that. And that kind of leads us into education. And I know that we get kids here, lots of kids here, right? And they go and they want to be part of it. And so I want there to be lots of opportunities in the community for them to make things, places to make things.
Well, it seems like you guys are doing a fantastic job at making that happen. Thank you very much, Dale. This has been really great talking.
Appreciate it.
My name is Lindsay Lawler, and this is why I come to Maker Faire. We have a giant electronic giraffe, which we call the Electric Giraffe Project. His name is Russell, and we've been working on him about 6 years now. He's up to about 2,000 pounds of iron, very friendly-looking iron. And what this is a big, gigantic experiment to see just how much life we can put into a ton of steel. He walks, he talks. He's like a giant treehouse for the kids to play on, and they just absolutely love it. And Maker Faire is always really delighted that we're here.
So what do you think it is about the giraffe and the entire project? Why do kids love it? What is the life that you've brought to it?
Having built something like a robotic animal, when you get the lines right between something that isn't 100% lifelike versus
not uncanny valley.
Yes, good. You know the uncanny valley. For those who don't know it, just look it up online. But yes, the uncanny valley is something you don't want to cross, because then it gets creepy and scary and people start pulling away. As long as you can maintain a cuteness factor that isn't threatening and get things just right, it's amazing what happens, because then you've put about 50% life into it and everybody else puts the other 50% life. When we first built this, it was nothing more than a framework. It didn't have any robotics or electronics in it at all, and people were just all over it. And I was like, wow, this looks like it could really go somewhere. It was just an experiment at the time, but the reaction from everybody was huge.
There are some delicate components on this, but for the most part, it's a ton of steel.
Yeah, it is a ton of iron. He's very robust. He can bite, he can chew, he can move his jaws. We have the computer asleep right now, but you can see here as I'm petting his nose, he's aware that I'm petting him, and he knows this by these little piezoelectric sensors. And we've put LED feedback on it now, so as you pet them, you see them change color. And this lets you know that the input is going into the computer and the computer is registering your touch. And that's the part that drives the kids completely crazy, because they see that not only do they get to touch it and feel it, but as they're touching it and moving with it, it's reacting to them. And that's what they really, really enjoy.
What's your name?
Austin.
Austin, what grade are you in?
5th.
5th grade. And have you ever breakdanced before?
No.
No. I saw you out there on the floor. What'd you think?
It was pretty cool.
Yeah, it's different from regular dancing, right?
Yeah. You have a lot more moves you have to do.
Do you think that you're gonna try out more of this breakdancing thing?
Probably.
Do you want to be like the b-boy at your school?
Probably not.
Have you ever been a maker yourself?
There's classes at my school where you build stuff, and so I've done that a little bit.
Very cool. And is this a better kind of day than a regular day in the classroom?
Yeah, a lot.
Try and get the teachers to make every day in the classroom a little bit more like this.
Hopefully.
Yeah. Do you have any message to science teachers out there?
Make some stuff for kids that can have fun.
So Todd, can you tell me a little bit about what you've brought here to the Education Day?
Okay, these are called the Land Sharks. I designed them for the desert art festival called Burning Man. It happens each year out in the desert and above in northern Nevada. And these are designed to drive around at night out there, and they appear to be living, breathing, swimming sharks that are floating above the ground a foot or two. So at night you see nothing but the shark going by. And it's designed to go play with people and go interact and chase people down. And people come up and design their own idea what they're going to do with me. They'll start playing the Saturday Night Live skit and talk about land sharks or candygrams and all that kind of stuff. Or they start doing the Jaws theme, and a whole chorus of people doing the dun 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 dun. People will jump on the ground and start swimming and say, attack me. I mean, they'll run and say, chase me. You never know what they're going to do. The girls will dance with it. The boys will pull out a handkerchief and say, toro, toro. I never know.
So what's the basis for what you've built? So is it a remote control vehicle and EL wire?
It's a remote control four-wheel drive vehicle, and I modify it by putting heavy springs on it, and then I build the shark-shaped basket that goes over it and put the wire on that. That's all welded out and put together. And the L wire is run by a black box converter it's a driver. It controls the animation on it, and it makes it glow as well. The very first one I made was taking a horse like this, putting on a remote control toy like this, and just playing with that. And it probably cost $25 plus the remote control, so $50 if you don't own everything. And
if you have to buy it from scratch.
But very easy to do. And there's a couple of other versions of it right there. So those were the first things I made, and I played with simple, cheap things, and just kept making more and more sophisticated things. And then I went to the sequence sharks, because I could just see the idea that if something floating above the ground, I could just picture that as being something that would work.
Yeah. And it seems like there's a huge response here. A lot of kids coming up and wanting to touch it and see what they're made of.
Yeah, the kids really love it. And at nighttime and during the day on Maker Faire last year, I had kids just going crazy, like the Pied Piper with the critters chasing. I was just calling the kids over here. They were having a great time with it, and it was very fun.
Chasing the land shark. Sounds like a good activity for a day. I'm Kiki. What's your name?
Abigan.
Abian?
Abigan.
Abigan. Sorry, I got that wrong. So Abigan, what have you seen here today that's really been interesting?
Well, the electric thing's over there, and it made music.
Oh, and they make music?
Mm-hmm. Yeah.
Tell me a little bit about that.
So basically, they're generating energy, and then it's causing that to make the music.
That's pretty cool. Have you ever made anything like this yourself? Anything that you like what you've seen here today? Are you a maker?
No.
Does this make you want to be a maker?
Yeah.
Yeah, you want to go back to school, go home, and be a maker?
Yeah.
Yeah. Is this kind of fun compared to a normal day in the classroom?
Yes.
Yeah. Do you want more school days like this?
Yeah.
So I want you to look straight at the camera and tell your teachers, what do you want more of?
More school days like this.
Excellent. I think that's something that we should all try for. Thank you very much, Abigan. Hey everybody, I'm at Maker Faire Education Day. You're the founder of Monkey Electric. Tell me a little bit about what you do and how you got your start.
Sure. Well, I got started. This was really just a hobby art project. Maybe 4 years ago, I just made a really cool bike light for my bike. And it was a light that I put onto the wheel of my bike. And then when I would ride down the street, everyone really loved it, and because it was a little bit of an artistic light.
A little artistic, but still safe, making you safe at night.
Absolutely, absolutely. And that was, I would say originally my goal was really artistic, but then I realized later that it was incredibly safe also because everyone would see me. And then after a little while, I decided to start a company, and now we manufacture and sell those lights. And really the idea is something that's so fun and artistic that you want to use it. And so you're really encouraged to be safe. And it also inspires other people to ride their bike at night as well.
Tell me a little bit about the technology that you're using to make the lights. What goes into what you build?
Sure. We use 32 full-color LEDs. That's kind of a new technology that's been recently available, and it really helped us to be able to do what we do. And then on top of that, we have a little bitty computer on every light, and the computer sort of uses what we call generative art, is sort of what the artists call it, which means kind of a randomization method where we generate patterns and stuff, and then we control the LEDs to do all the cool stuff they do.
Now, what made you come to the Education Day and stand here and tell kids what you're doing?
Well, it's always a great opportunity. I think, a big part of our mission as a company is to get bikes, to get people more aware of what they can do on a bike, and that biking is safe and fun, and you can get anywhere by doing that, and that applies to all ages of people.
How's the response? What do the kids seem to be thinking about what you've brought?
Oh, gee, they love it. I mean, we can't really, we had to fend them off with a fork. I think.
You've got brooms.
Yeah,
Don't touch that. Get away.
Right. Exactly. Yes.
Have you been here in previous years?
Yeah, we've been here every year since it was started.
And have you had people come back and go, "Oh, you're back again"? Is there any kind of repeat?
Yeah, definitely. We definitely get some people that love to see us every year, and they say every year they even recognize what we did that's new this year.
Excellent.
Get yourself a little cardboard barrier around your projector, you know what I mean?
Dr. Nuclear.
Yes, ma'am.
Tell me what you have brought to Education Day today. I know I need an apple box.
I have brought the Wii Interactive Whiteboard System and my fine IR pens.
So tell me, Wii Interactive Whiteboard System, how did you create this?
Well, the major idea came from Johnny Chung Lee. He put a YouTube video out there. It's got 4.7 million hits now, and it changed my life.
Wow, so a YouTube video changed your life.
It did. I first saw it about almost 2 years ago now, and I thought, hey, I can make IR pens, so I created a company around it. It's called Whalebone IR and Software.
Okay,
and what this is an interactive whiteboard. So it's like the old whiteboard marker boards, except it's interactive. It's done with a computer, therefore everything in it is virtual, and you can erase it with one click. You can redraw with one click, and it can be a PowerPoint or it can be software even. It's basically, you can think of it as a super graphics tablet.
Right, but on the wall.
Now, normally to create this effect, you need $2,000 or $3,000 to buy a board that works with a capacitive wires inside of a large screen. But Mr. Lee figured out that all you really need is an IR camera that's built into the front of every remote control. And then
right, so you have the camera that senses any infrared.
Right. So you give it a little infrared light source, a little IR LED built into an IR pen. I make and sell these. This one was created simply by going to a 99-cent only store and buying a toy car. And then I just use this part and I throw the car away.
And a tongue depressor.
And a tongue depressor. And then
otherwise known as a big popsicle stick.
Or a craft stick for us sophisticated artisans. We use a resistor for better battery life, and we use the IR LED at the tip. This is the exact same IR LED that Johnny was talking about on his website and in his video. It's the Vishay 6400 IR LED. Your computer has to have Bluetooth connectivity. Most do not come with that from the factory, but cheaply you can buy a USB dongle, which you see flashing right there, and that plugs and plays right with the computer. Don't get my phone number on camera, please. And then it will talk to the Wiimote, and it will be sending back information about where those IR LED dots are 200 times every second. And with that in hand, the software can create a mouse effect, or it can create lines or shapes or whatever you want. So basically all the controls that you can go over to the rectangle panel and use, you can bring them up wherever you are in that fashion.
Great.
And you have a white screen or a gray screen that's built into the software. You have different thicknesses of lines. you have 8 different colors, and you have a pen or a highlighter. The difference is that when you use the highlighter, it doesn't completely cover up whatever is on the screen already. It just makes it that color, kind of a little bit opaque. And then you have shapes. You have an arrow if you want to bring attention to something. And very cool difference between an interactive whiteboard and a regular whiteboard. If you made a mistake on a regular whiteboard, you're there with the eraser going, oh wait, give me a second.
Depending on the whiteboard, you might have color smudged everywhere.
Exactly. In this system, undo, undo, and you're undone. Oh wait, I didn't mean to undo it. Bring it back. Redo, redo. And if you've created something that you really like and you want to use it in a classroom the next day or something like that, you can snap a picture of the screen and it'll save it to a JPEG file on disk, so you can bring it back and use it in another software later. If you don't want to erase the whole screen at once, you can use it like a standard eraser, just like that. If you want to erase the whole screen at the same time, you double click.
So how much does this system, I mean, we know that the projector is going to cost some money.
That's the big nut to swallow, yeah. The projector is the big thing, $400 or $500 minimum.
But if you're, say, a teacher in a classroom and you've got access to a projector,
right,
what is the rest of this system going to run you?
I can bring together all the other elements for about $180. Or you can piecemeal it together yourself. Like if you already have a Wiimote, you're not going to want me to sell you a Wiimote. If you already have a Bluetooth dongle, you might not want that.
So if you have a computer with Bluetooth, you have a Wii at home, so you've got the Wiimote, you've got a bunch of the stuff that's going to take you down to well under $100, isn't it?
The only element that you won't find in stores are IR pens. And they're pretty easy to make yourself. Either I could sell a kit or I can sell you a fully made IR pen. This is my other model over here.
Ooh.
This is nice, huh? Yeah. This is the longest IR pen in the world. I call it the Sword 2. It started out as a kid's lightsaber toy. And then I just took out the LEDs that it came with, and I put in the famous Vichy 6400 IR LED at the tip. It has batteries already, it has a button already, and I'm ready to rock.
So you've got more reach.
Exactly, and this also makes it easier to stand out of the way of the sensor. And it makes it easier for your class or your audience to see what you're drawing.
Because you're not standing in front of it.
Right. It's good practice anyway. Ready to rock.
Tell me a little bit about who you are and what you've brought to the Education Day.
Hi, we're smtboards.com out of Las Vegas, Nevada. And what we're bringing to Maker Faire this year are surface mount technology. We only solder to one side of the board, and what we're trying to prove is that this is a simple enough technology for anyone to use. On our website, we produce all of our kits. They're in the public domain. Every kit design is downloadable. However, you can also buy them, of course, from our site as kits. We actually make all of these kits at home. This is an example of a board that we've made.
Do you have your garage set up, or do you cook the boards in your oven?
We cook the boards in the closet.
In the closet?
In the closet. So anyways, this is an example of a board that we're currently making. We've etched this in our closet, and then we use a very tiny table saw to cut them. It is tiny. And then we use a very tiny Dremel drill, and we're able to make these into all different kinds of shapes. We have things like SMT light boards. These are different colors, red, green, white. We have something called a demon eye. This actually flashes back and forth. So this is something for like Halloween that you would put in your bushes that would show demon eyes. This is a kit we call SMT Blinky. It's a blinking light. It will blink for 57 hours. And then this one is kudos to a gentleman named Dale Wheat. Dale Wheat made a board originally called the Tiny Cylon. I said, Dale, that Tiny Cylon is kind of big. Would you mind if I made it smaller? He said, go right ahead. So this is our version of a Tiny Cylon. And when you push it, it actually sequences into different programs. And as you can see, everything is soldered to the surface of the board. This is actually a tiny 13 CPU, a button and a battery, and 5 LEDs.
And all of these boards are all fully assembled, so you take the board and then you can incorporate it into whatever you happen to be building.
This would make a good control circuit. If you want to make your own Knight Rider, then you might use this to, let's see if I can find the Knight Rider circuit. I think there it is. Yeah, that's the Knight Rider circuit. So you could use this as a control circuit for other systems. Now, we sell these mostly as kits on our board. We do sell pre-assembled Cylons. The problems that we had with doing something like this was there was no cheap way of programming that tiny CPU. As you can see, it's about the size of a tick. So we were able to actually create things like the Tiny 13 ISP, which is a little tiny board in itself, but we're able to clamp the Tiny 13 to the board temporarily to program it and then place it in circuit. And then we've done things like the Blinky, a tester circuit. This is what an SMT tester looks like. It allows you to test LEDs to see if they work.
Yep.
Come on. Okay, it's hard to do backwards. Okay, but not only normal LEDs, also surface mount LEDs. It's got size for 12s, 1208s, 805s, and 603s. So you simply place the LED across it to test it.
Good to know if they work before you put them into whatever you're building.
Yeah, best to test before you solder in permanently, because those things are really hard to get off the board.
Yep.
The last thing we have is something called a multi-ISP. This is a programming header. This header attaches to something like a USB Mini. This is a normal programmer in the industry. Adafruit sells these. And you're able to put a 4-pin, an 8-pin, or a 20-pin chip. It provides a clock, and you can program any kind of chip that you might need. So our idea is to produce tools that are useful to other people and blinky things. So
Tools and blinky things.
Tools and blinky things. That's us. smtboards.com.
Practical and fun. Are you getting a good response from kids? Are there a lot of kids who are interested in making use or even finding out what it is that you have here? Like, what is this stuff? Are they coming up and asking those questions?
I think they like the blinky. Things are blinky and bright. So, yeah, our hope is to foster technology in students. I was sparked as a young child. My grandfather was an inventor. So I've always been very interested in electronics. The ability to be able to create something like this at home is fantastic. Make Magazine produced these instructions about 2 years ago. They sparked us on to do this. So thank you, Make.
Signal is being sent to a microcontroller, which is this. That's the brains of the operation, and that's actually what's creating the control signal that controls the Tesla coils. And the way that the actual spark makes music is it does it by turning on and off very rapidly. So say that we want to play an A at 440 hertz, then what we do is we turn the Tesla coil on and off 440 times a second. Every time it turns on, you hear a little pop, but when you put a bunch of them together, it actually forms a pitch. So we're actually using the electricity to vibrate the atmosphere to create the sounds that you're hearing. And I just write another one. We'll answer questions after the show. Kiki. Once again, we are Architect from Austin, Texas, and we're going to be walking around front here if any of you guys have questions, and I hope you do.
Can you tell me your name and why you came to the Maker Faire today?
I'm Isabella, and I came because it's a field trip, and we thought it would be cool.
And is it cool?
Yeah, it's really cool.
What grade are you in?
5th grade.
5th grade. And how is this compared to your normal science in school?
It's way more fun because you can actually interact with it.
Yeah, so does interaction make it, the interaction part of it is the big deal. It makes it a lot more interesting. And
yeah.
Do you think you're learning stuff today?
Yeah.
Excellent. And what's your name?
My name's Priscilla.
Are you in 5th grade also?
Yes.
And what do you think about the Maker Faire Education Day and what you've seen here today?
It's the best and it's awesome.
What's your favorite thing?
My favorite thing, I think, was the soda, where they put the Mentos in the soda and it all exploded.
A little messy, but fun.
Yeah.
Are you going to try that at home?
No.
No?
There's 7 kids at my house, so.
It could be a fun group project.
Yeah. It would be fun.
Try and talk your parents into it. What's your favorite thing? What was your favorite thing that you saw this weekend?
My favorite thing so far is probably like the lightning. That's really cool.
The music that comes out of it?
And probably like that big like sphere type thing that's made out of like the metal circles.
Mm-hmm. And seeing all this stuff and getting to interact, do the two of you think that do you want to go make things now? Has it inspired you to do anything?
Yeah.
Yeah.
All right, so I want you to just look at the camera, and I want you to tell your teachers, this is better than the classroom.
This is better than the classroom.
What's your name?
Aria.
What grade are you in?
7th.
So what's going on here?
We're trying to see if the tin can telephones will work from the other side of the room.
This is a really long, are these balloons or rubber bands?
These are just string, ribbon.
Just string, okay.
Mm-hmm. And, okay.
Okay, listen. Can you hear anything?
No, we can't.
Pull it tight. Oh! Try and find the limits of the tin can telephone. I'm glad you're testing the limits of science.
Yeah, it was fun.
Excellent, thanks.
So this one is being ran backwards to generate the fuel, and here we're running it in the forward direction where it's running the motor.
So what's the loss efficiency on that?
Well, for the efficiency for electrolysis is about 45%, numbers like that. If you equate the amount of energy needed to heat electrolysis versus the amount of energy.
Jeff, you are an electrical engineer, and here at Maker Faire, you don't normally expect, a big company to be making things, but you really have a maker story of the biomedical technology that you and GE have brought to the Maker Faire this weekend.
Yes, we do.
Can you tell us the story? What is the maker aspect of what you've built here?
Okay. Well, in short, what we've done is starting out on a project with a security system, so a home security system that we make. We realized that we had some problems where the security system would get armed while people are home at night, and during the night one of their pets, their dog particularly, would go downstairs and it would trigger the security alarm.
My family recently had an event with a Mylar balloon.
Ah, yep, absolutely. And what happens with that is then you're on the phone and you're explaining it's just a false alarm, or you're putting the code in and silencing the alarm. So our security business asked us to look at the signals coming out of that sensor and figure out, could we actually use it to tell the difference between a person and a pet? Mm-hmm. As we got into it, what we realized is that we were seeing people's breathing and their heartbeats. So although we continued to work on the security aspect of it, we figured out very quickly we could use this for healthcare monitoring, particularly for monitoring people when they're reluctant to wear a device or not able to wear a device.
So what aspect of the technology that you're using is picking up the motion, the breathing of the motion of the rib cage, the motion of the muscles of the heart? What is picking that up? What kind of signals are you looking for?
Yep. So in this case, the sensor that we're using is a Doppler radar. So it sends out a small electromagnetic pulse. As that pulse hits objects, it reflects back to the sensor. And we're using what's called the Doppler effect. So anything that's out there that's moving will come back at a slightly different frequency. We're able to tell that it's something moving, and we're able to record that signal. The phenomena, what we're measuring on the body, is what's called a ballistogram. And the ballistogram is that movements on the surface of the body happen because things are happening inside the body. So you can imagine your heart is mechanically pumping, it's beating, some of that motion shows up on the surface of your body. As you breathe in and out, obviously your chest expands, your diaphragm moves, and some of that motion shows up on the surface of the body. And we've made the security sensor very, very sensitive so it can pick up those very subtle motions.
So you're not just looking at the something off the shelf from Home Depot that's picking up the ballistogram.
We're looking at something that's very close. The interest in this device is it's very inexpensive. It's a consumer product. And with some very minor modifications, you can make it sensitive enough to pick up the types of signals we're looking at.
And so this will be used for patient monitoring so that you can get rid of the wires, right?
Yes, but it'll be used in certain settings. And we think very much if a patient is in a hospital, they're still going to wear a medical device. So a lot of our work at the Research Center has been on making those devices miniaturized, making them very small. And the ideal vision for that is we can get to a cost point that's low enough that you can essentially peel open the sensor, you can stick it on the person during their hospital stay. When they're done, you peel it off and you dispose of it. But outside the hospital, it's a different story. Not everyone will use a monitor. Not everyone will wear a monitor. And a couple examples for that, let's say you have early onset diabetes or you have high blood pressure. Your doctor tells you, here's your glucose meter, here's your blood pressure cuff, measure these 3 times a day, chart them all down. At the end of the month, come back and I'm going to look at the chart and we're going to figure out if your therapy is working or not working. So people usually do it diligently for the first month. They go to the doctor maybe looks at it for 30 seconds, doesn't really say anything, and now the people say, I'm not going to measure it anymore.
What's the use?
Right, what's the use? Why bother? It's difficult. I have to find the cuff. I have to put it on. It takes time. So we're looking at technologies essentially that can get built into objects. So let's say it's placed in front of your easy chair that you like to take a nap in every afternoon, or it's placed over your bed where you don't have to do anything. It does it automatically. It can recognize that you're there. It measures these parameters when it can, and at the end of the month it automatically transmits it back to the doctor's office so they can look at those types of trending.
That sounds awesome. Like it's a step in the direction of the smart home, but your home is not just smart in the sense that it senses your presence and turns on the lights or turns the lights off. It's actually measuring health parameters.
Absolutely.
Yeah, that's fantastic. What do you have here in these devices?
Okay.
What do we get to play with here at Maker Faire?
This device is our in-body bioimpedance measurement device. And I use the analogy for this device is essentially electrical engineers measure impedance all the time. You measure resistance, you have a multimeter, essentially it's measuring impedance of electrical circuit. This actually measures the electrical impedance of your body. Traditionally what people use is the doctor will record your age, your gender, your height, and your weight, and they'll convert it to body mass index. And body mass index is a useful thing to measure, but it's not always that accurate. Some people may have a very high body mass index, and they still may be very healthy, which means they have very low fat content. So you can think of weightlifters as one example. Some people may actually have a body mass index in the low range or in the normal range, and they may actually have a large percentage of fat. So what this device does is it actually measures the body's electrical impedance in addition to those parameters, and it can tell you the water content of your body, the lean mass content of your body, and your fat mass of your body.
Not something I want to know right now. Well, I just had a baby.
Yeah. So how it measures it is it sends, just like we would measure an electric circuit, it sends a small signal through these hand grips. So if you look at the hand grip, you have an electrode for your thumb and one for your fingers. You step on it with bare feet.
Is that kind of like an exercise machine where you put your hands on the exercise machine, to get your heart rate or that?
The exercise machine is measuring the electrical signals generated by your body. This one's actually generating some very small, safe electrical signals and passing them through your body to measure those components. On the foot plate, you have an electrode for your heel, you have an electrode for your toe. So you would stand on this with bare feet. It'll take your weight. It'll actually ask you for your age. It'll ask you for your height. It'll ask you for your gender. And then over the course of about 30 seconds, you'll hang on to both of these hand grips. It'll go through, and what it does is it measures between your two arms. It measures from arm to leg, it measures from leg to leg, and then it measures the combination of all of those. And it approximates what it measures as essentially an electrical circuit of your body. And with that, it can actually separate out. It can tell you at the end of it what's your water mass, or what percentage of your weight is actually water, what percentage of your weight is fat, and what percentage of your weight is dry mass. And that's a much more effective indicator of the health of someone than just looking at body mass index alone.
Yeah, because you're getting a much more complete picture of what they're made up of.
Correct.
And then you can have actionable, you can actually have something to do about it. So if you know that you've got too much fat versus lean mass, got to exercise.
Yep. Now, there are techniques that are much more accurate. If you went for a bone mineral scan, you would lay on a table, they would use a very low energy x-ray, and they would tell you essentially your bone mineral density. That's much more accurate, but it's also, it is an x-ray. And it is something that you'd only have done very infrequently. This doesn't use any ionizing radiation, so you could use this every day. You could use it several times a day. And of course, you can see here it's much different than the large X-ray machine. So this could be in your doctor's office, your fitness center, and even in your home.
Yeah. And people who might ask about the production of the electrical current and how your body would react to it, our bodies are conducting electric currents constantly inside of our nerves, and probably the current is so low that it's not going to be something that would affect you. But if somebody has pacemakers, is there any concern?
We do say a contraindication of this is someone with a pacemaker or an implanted device shouldn't use this. And that's really because there isn't a way for us to go and test every configuration and every device that's out there to make sure it's absolutely safe.
Well, thank you very much. I appreciate your time.
Thank you.
Well, today was a lot of fun. Kids obviously were having a great time. So I'm looking forward to day 2. We're going to be here with Ayaz, looking at all sorts of fun things that people have made and brought to share. So stay tuned for more. I'm going to take a load off, maybe take a ride around.